11.3, geometric sequences and series. A geometric sequence is when the terms are found by multiplying by a fixed number. So you might remember last time an arithmetic was when we added, this time geometric is when we multiply. Terms found by multiplying. Multiplying by a fixed number. So for example, if you started out with 1 and then went to 2 and then 4 and then 8, you can see that it's times 2 times 2 times 2 times 2 times 2. That is geometric. The common ratio this time is that number. That number we multiply by. So in this example up here, r is equal to 2. The ratio is 2 because we're doubling it, times 2 times 2 times 2. All right, so we have a formula for the nth term of a geometric sequence. This should remind you of when we had the arithmetic. We need to know the first term, a1, and we need to know that common difference, r. Example 1, a person receives a gift on the first day of each month for a year, starting with $50 on January 1st, with the amount doubling each month. How much is received on December 1st? So this is an nth term question, all right? They want to know what we get on December 1st, which happens to be the 12th month or the 12th number in this list. They tell you what we start with, so that must be A1. And then when they say it's doubling, they're saying times 2 times 2 times 2. So recall that formula was AN equals A1 times R to the N minus 1. That's the formula. So if we want to know the nth term, or in this case the 12th term, we're going to take that first term, 50, and multiply it times that R to the 11th power in this case. 12 minus 1 is 11. So let's do that. 50 times 2 to the 11th power. 102,400. $102,400. That is the amount that we would get, or that is received on December 1st. Number 2 says find A5 and AN for the geometric sequence. Well, they tell you it's geometric, so that means it's multiplied. If you look at this, I think your common sense is going to tell you to divide by 4. Divide by 4, divide by 4, divide by 4, divide by 4, okay? But we can't really talk about division, all right? We have to talk about multiplication. So instead of divide by 4, I'm going to say it's multiplied by 1/4, which is essentially the same thing, right? So R is 1/4, even though it makes more sense to our brains to say division, we've got to say multiplication just because that's what the formula does, all right? So it's pretty easy to find the 5th term here because we've already got the first 1, 2, 3, 4 terms. So really all we'd have to do is multiply by another 1/4 and get 25. I can see pretty quickly that A5 is equal to 25. We don't really need any formulas for that, okay? But let's find AN. So AN is equal to A1 times R to the N minus 1, right? That's the basic formula. But we know A1 is 6,400. And we know the R is 1/4. We don't know N yet, and so that's kind of your clue that you're going to have to leave an N in there. AN is just going to be a formula with an N in it. That formula right there would give you that nth term. And so if you plugged in N equals 5, it's going to give you our 25 for the 5th term. I think this problem would have been more interesting if they had asked you for like the, I don't know, 20th term or something, okay? If they had asked you for 20th term, we could just use our formula, 6,400 times 1/4 to the 19th power. When do we get that? Okay, 2.3283 e negative 8. So hopefully you remember that means times 10 to the negative 8th. That's about 2.3 times 10 to the negative 8th. And remember what that does. That just moves the decimal 1, 2, 3, 4, 5, 6, 7, 8. Or a decimal with 1, 2, 3, 4, 5, 6, 7 zeros. So that's a really small number. I know they didn't ask for A20, but I'm just saying that I think that would be a more interesting question. And that number should make sense because you're taking the 6,400, divide by 4, divide by 4, divide by 4, divide by 4, divide. You're dividing that by 4, and you keep dividing, so it should make sense that you got a really small number here. We're never going to dip into the negatives. It's just going to keep getting smaller and smaller and smaller, closer to 0.